Okay, so you don't have a question. Let me go with the chapter 5. It's everything about the repetition structure. So if you remember that basically we have the three types of structure. Right? The first one is sequence structure here. That means everything in order from the beginning to the end. The second one is selection here. Selection, that means you always have the condition to check. You always have the condition to check, and you able to break it down the branches here. The branches, yes, do something, no, do something. And you able to use a netted selection also, right? So it's no, again, you check the condition here, yes or no. And again, you can check it in the netted here. And the third one is repetition here. Repetition. Repetition is a looping here. That's a looping. So working with the loop is a block of a code, right? It's the first thing you have to definition here is the loop is a block of the code, and under certain condition, that is you have to pay attention here. It's a selection. So whenever working with selection or whenever working with the loop, you only need the condition here. It's certain condition. Right? So it's under the certain condition, it will be executed repeatedly. So it normally you have the condition here. So if you have the condition is yes, you do something and do it again and again and again until the condition is now here. That is you have you have to keep in mind that whenever working with selection or whenever working with the loop, you only have the condition to check it. Right? So think about this one is example here. You have the number, it's a variable here, right? So you have to repeat until it is a loop here. So the first one you have to write, enter the number. Now you store the number in the variable name here. Sorry, number here. Right? So when you store the number, say at the beginning, you enter the number 10, you store it in the variable name. It's a number is 10 here. Now you print it out number, so we just print out number 10 here, right? So the next one, you check the condition here. This is the condition here. This is condition. You check number equal to 0 or not. The 10 here is not 0, right? So when it's not 0, you come back. You come back to the loop again. You come back to the loop again, and you do enter the new number. So next time you enter the number 5 here. You print out the number 5, and you check the condition again. The number 5 here is not 0. You come back again to do one more. So next time, this time you enter the number 0 here, right? You enter the number 0 here. Now you write down the number 0. You check the condition. Number now is the 0. You stop. You exit the loop. So this one is condition here, right? So when you have the condition for this one, you exit the loop. If not, you keep doing it here.
So a quick question. So the three basic constructs are sequence, selection, and repetition. So all loops have all three of those?
No.
Oh,
So
okay.
you have the three structure. The first one is sequence. The second one is selection, and the third one is the repetition. Now,
Okay.
so the sequence that you just do it normally from the beginning to the end, one by one, one by one, one by one. For the selection, you break it down into branches here, and you have the condition here. All right. So the third one is the loop here. The loop here is the repetition or the looping. So you also have the condition to check. If yes, keep doing it, keep doing it. If no, you exit it here. So it's up to it depends on your coding, it depends on your program. Sometimes you can use a sequence, sometimes you can use a selection, sometimes you can use a repetition, or you can use a combination, all of them. It depends on the program, right? So we think about if you have a complicated program here, you have to do a lot with the sequence, you have to do a lot of selection, and you have to do a lot with the repetition here.
Okay.
Okay. For this chapter, we just mostly focus on repetition. But when working with the chapter 6, 7, or when working with the final project, you have to use a combination, all of them together. Okay, so oh sorry, I forgot to share the screen. Okay. So if you look on this one, you see you have the condition here to check, right? So first one, you enter the number. Now you store the number in the variable number. Now you print out the number and just check condition here. So whenever the number equal to 0, you exit the loop. If not, keep doing it, keep doing it, keep doing it here. Okay, so you can do the looping simulation with the Raptor. So if you're working the Raptor here, so with Raptor, you see that if you remember with the Raptor, everything here is input, output here. You have, if you're working with the modular structure, you have a core function here. You have assignment, everything with calculation, right? And you have the selection. Is that what you did with the chapter 4, working with the bracket, and you have the loop here. Right? So now if you come back to the let me open this one. Okay, so if you look on this program here, not this one, this one. If you look on the program here, you have to input the number, you have print out the number, and you have to check condition here, right? So you can do it with Raptor. You can see the first time is the first thing you have to enter the number here. So we have to input here. Okay, and you look on this one, when you have to enter the number, you print out the number, right? You print out the number here. So you can have the output, you print out. Now you see, actually, whenever you see the repeat and until here, it is a loop, right? It's a loop. So when it's a loop in the Raptor, this one is a loop here. This one is a loop here. So you have to drag and drop the loop. And if you look on the condition here, it keep doing it until the number is 0. So whenever the number equal to 0, you exit the loop, right? So you have to put the condition here. Is the number equal to 0 or not, right? The number equal to 0. You see, if the number equal to 0, you exit the loop, right? If not, if keep doing it. So we see in the case of that, you have it here. You have to put in the loop here. So the first thing you have to enter the number. You print out the number. Now you check if the number equal to 0 or not. You exit the program. If no, keep doing it. Keep doing it. Keep doing it here, right? So we can run. You can see now. Say if I enter the number 10. You see, you store in the number 10 and print out the number 10. Now, if I enter the number 5, you keep doing it, you print out the number 5. Now, if I enter 0, right? You see, if I enter 0, you print out the number 0 and you check the correction here. If no equal to 0, exit it here. Okay, so we see, I enter the number 10, I enter the number 5, and I enter the number 0, and print out all of the 3 numbers here. Okay. Any question for this?
Nope.
Okay.
So that's a selection loop.
Loop selection is when working the branches. When working in chapter 4, right? When you see the loop here, it's a keep doing it for multiple times. But for the selection, you only do it for one. Each one branch it here. Okay. Okay. Okay, so if you look in the flow chart, you see the first thing is that you have declared the number. Now you enter the number, you write down the number, check the condition here. If the number equal to 0, right? Exit the loop. Now, no, keep doing it forever here until the condition is met here. So we have the definition of iteration. I don't know, it's iteration or iteration. Well, what do you think? What should be the correct pronunciation for this one? Iteration, right? Okay. Okay, so iteration is how many times the loop will run, right? So for each time the loop run, it's the called iteration here. So think about this one. If you look on this, this coding here, the first thing you declare the name as string. Now, whenever you have the repeat and until, it's a loop here. So the first thing you write, you asking the user to enter the name of your brother or sister. You store it in the variable name. You store it in the variable name here. And now you print out to the output here, and you check the condition. If the name equal to done, you exit program. If not, keep doing it here, right? So think about if you have the example here. If a Jim have the two brother, right? Two brother and one sister. Think about you have the two brother. It's John here and Adam here, right? And sister, you have the Julia here. So now, how it's run? The first thing you enter, what is your enter your name of your brother and sister. He enters John here, right? He enters John here. Now the pronoun John here, right? Now you check the condition. The name equal to none, to done or not. John is not equal to done, right? So it's not correct. It keep doing it here. Keep doing it here again. Enter the name. You enter the new name here. Now it's override this one. You have Adam here. So when you have the store in the Adam, you write down it's Adam here. Now you check the Adam is not equal to done. Keep doing it one more time. Now you enter the Julia here, right? So now it's override for this one. You have a Julia here. Sorry. Julia, store in Julia, print now Julia here. You check it again. Julia is not equal done. One more time, right? So what happened here? What do you think? How can you exit the program here? How can you exit software? When you were able to exit the program?
Done.
Yes, right. So you have to enter done here in order. But what happened here? If you enter done, if you enter the done here, it stores done here. If you store the done in your name variable, and again it write down not done here. So we check name now done equal to done. It's correct. Exit program, but you think but what you see here is that you only have the two brother and one sister, but it runs for the 4 times here. John, Adam, Julia, and Dan here. So we see you have the two brother and one sister, but this program you require for the 4 iteration. And if you think you have a Maria, only have one sister, it only have the 2 iteration here in order to exist. You have the one sister name and the done here. Right? So the question here is, can we create the loop that doesn't use the test condition at one of the iteration? You see, for all of them, you only have one more iteration is done here. Right? So that's why even that you have the 2 brother and sister, you have 4 iteration. So what do you think? Can you create a loop that don't use the test condition as one of the iteration here? Yes, yes, you can do it, and I'll show it later here. And when working with the loop, you always have to be aware of the infinite loop here. Infinite loop, that means you have the condition here to check, and whatever it always the correct. That's why it keep doing it forever. So when working with the program, and if you have the infinite loop here, it consumes time, it consumes a lot of processing, it consumes a lot of the memory here. So that's why if you are the programmer, always think about always be aware of the infinite loop here. So if you look on this program as an example here, do you know why? Can you see why here? You have declared the computer number integer, you declare the number integer here, you have repeat and until here. And whenever you see the until, this one is the condition here, right? This one is the condition. And the program here is only exits the loop when the condition here is true. It's only true. right? When it only exists when the condition is true. Now, if you look on the inside the loop here, you enter the number, right? So the first one, you have number here. Number. The second one, you set the computer number equal to number. That one, you have a one computer number here. And this one, computer number is the number plus one here. So we think about you enter the 10 here, computer it's 11 here, and if you enter the 5, computer is a 6 here. And you check the condition here. You have number greater than computer number. No way, right? You have no way because computer number here is only equal to number plus one. So you have no way to have the number greater than computer number. That one is always 4 for whatever it is. So when it's a 4, this condition here, it keep doing it, keep doing it, keep doing it forever. This is infinite loop here. So when working with the loop, you only have to be aware of the infinite loop here. Sometimes you run with the loop here, and you have to find out what is happening with the loop here, and you have to look it back on the condition. So the condition of the loop is very, very important here, and you have to always check to make sure that you have no infinite loop in your program here. And the second one, when working the loop, you also have to pay attention with the here, and don't let the user get trapped in the loop here. Now come back to this example here. Come back to this example here. You can write this this example in the Raptor. So let me working with this one with the Raptor here. Let me check this. Okay, now I do another one. Okay, so now do this one with the Raptor. You can do it with the Raptor here. So for this one, you see, you have the loop, right? You have the loop here, and in the loop, you have enter the name of your brother and sister here. You have the input. And you store the name here. Now the next one, you have to write down, right? You have to write down what the name it is. So we have the output here. You plot it variable here, right? Now the condition here, you check. You have to check if the name equal to done or not, right? Okay, so now you see if I have enter the John here, it's my brother. Now Adam here is my brother, and Julia here is my sister. Now, what happened if I want to exit program here? What do you think?
Right, done.
Yes, but the thing here, you have to think about the end user. This is the coding, you are able to look into the coding, but from the end user, they have no idea what is in the coding here. Right? So when working the loop here, you only have to specify, you only have to tell the user that how can he or she exit program here. So instead of that, you see, instead of doing this one, I can do it a better way here. I can do it a better way. So I can tell the user that enter done to exit here. Okay, so from the user point of view, they have no idea what is coding inside, but all they know is only the prompt of the program here, right? So we run it here. All he knows is that by looking at this one, right? So he understands that in order to exit the program, he had to enter down here to exit, right? So now I put this John again, and then again, you see it's a 2 iteration, right? Julia here, 3 iteration. Now I put done, it's a 4 iteration, right? And you see, I print out John, Adam, and Julia done here. Okay, so that is a thing you have 2 things you have normally. For now, you have 2 things you have to remember when working the loop. The first one is be aware of the infinite loop here. The second one, you be aware that you don't let the user get trapped on the loop. You only have to specify, and you have to tell the user how can he or she exit the loop here. That's the thing you have to pay attention when working the loop here. Any question for this?
Nope.
Okay. Okay, so we see for this one also, right? You don't let the user get trapped in the loop. You have to specify with the user that you enter the name, and you have to tell him how he can exit the loop by telling him that enter 0 to end program here. So we see and enter the input, write out the input, and check the condition here. Check the condition number equals 0. That is the one you tell the user how to end the program here. Okay, so we review about the comparison and assignment, and you know that if you have a single equal sign, it is assignment, right? So we think about if you want to set then the variable x to 10, you have a single equal sign here. So after that, you have the variable name is x here, and you set the 10 here. And the next time, if you change, if you want to set the 10, you're able to do 20 here. So now it overrides the 20 in the memory here. And for in the case that if you want to compare the 2 variables together, you have to use the double equal sign here. That's the thing you have to remember about that, right? So when you want to compare x equal to y or not, you have to use a double equal sign here. So in that case, if you have x here, 10, and you have y here, it's variable 20 here, right? So it pull out x here is 10, and pull out y is 20. And they compare them together, and 10 is not equal to the 20, so the output of this one is a 4 here. Okay, so remember that when working the selection and when working the loop, you only have the condition to check. You only have the condition to check, and in the condition here, you can use a relational operator, right? Everything about equal or not equal, less than, greater than, less than or equal, or greater than or equal. And you can use a logical operator. Logical operator, everything about not and or, and they are compound condition. So when working with the logical operator, you can compound multiple operator together. Multiple condition together here. Right? So here you have the logical operator, and if you want to review, you have the and or not here. I think about the and. The end condition is the output only true when both of the input is true here, right? You think about that. If x greater than 5 and here, and x less than 10, so it's only true when here you have the negative infinity and you have a positive infinity here. So this one is only true when everything in the range from the 5 to 10 here, right? You have the 5 to 10. In any other range is the 4 here. Okay? So by using and or not, they are the compound operator, and you're able to combine multiple conditions together here. So see, you have this one, if x greater than 100 and not x equal to y. That's, you see, you combine and not also for this one, or you can use all here in the condition here. Right. So if you look on the flow chart for this one, right, you enter the number, input the number, you check the condition here. If the number equal to 0, actually it's double equal here. If yes, and exit the loop, no, keep doing it here, right? Okay, so now we have the shell check. What number will we display? It's a code. Correct me to the following pseudocode run. Set, repeat, set. So we look on this one, right? What do you think? What should be the output of this coding here? Think about that. What do you think? What should be the output of this coding?
Oh,
3.
3.
Let's tell it and tell me.
Or 1.
What is the output of this one? What are the output?
Right, 2 times. Would it be 1 because 2 times 1, and then that number would be plus 1, so 3. So it'd be just the first one.
Okay, so tell me what are the output of this coding? You have to think about how many iteration, and you have to write down all of the output here.
Just 1 iteration.
One only. Okay, now look, right? See, you have the variable here, number. Right? You have the variable number here. At the beginning, you have 1. Now, what you do? You repeat it, you write 2 times number. What is the number? Number is 1, right? So we write 2 times number. That means that the first one, you print out the number 2 here. You print out the 2 number. Now, you set the number equal to number plus 1. So the number now is a 2 here. Okay, the number now is 2 now. The next, you have to check the condition. Number equal to 3 or not? Not, right? It's not. Keep doing it. Come back. Keep doing it. Come back to this one. Again, you write 2 times number. Now the number 2. So 2 times number, you write out the 4 here. All right? And you set number equal to number plus 1. So now number is 3 now. You check the condition. Number equal to 3 or not? It's correct, right? So it's correct. You exit program. So actually for this coding here, the output will be 2 and 4 here.
Okay.
You got it?
Yeah.
Yep.
Okay. So how about the second one? Let's do the second one here. Okay, now do the second one. And tell me what are the output here.
Was 6 and 3.
What are the output? You have to do the first thing, you have to working on iteration, right? So what is the first iteration? What is the second iteration? And what is the third? And so on until the condition is correct here.
Yeah, 6 and 3.
How can it 6 and 3?
Well, because I went through 3 iterations.
Okay. No, I asking you what are the output here? What are the output? So what do you think? What are the output? Output everything in the right here, right? You see, whenever you see the right, they are the output here. So what do you think? What should be the output they print out on the screen here?
2.
Anything else?
6.
Okay, now do it by iteration, step by step, right? So now we see, do the same. You have the variable name is the number here. Now we see, it's at the beginning, you have the set number 1 here, right? So now we come to the loop. The first right here, what is the output for the first one?
2.
Yes, 2, right? So now you set number equal number plus 2. Now number you increase by 1, you have 2 here. And you check the condition, number greater than 3 or not? No, keep doing it. The second iteration. So what is the output for this output? So for the second iteration here?
4.
Yes, 4, because the 2 times number now is a 2, right? So that you have 4. Now the set number equals the number of plus 1. The number now 3, right? And check the correction. 3 greater than 3 or not?
No.
Not. Keep doing
No.
it again. Keep doing it again. So now you write down 2 times number now 3. That's why you have 6 here. Right? And the number equal number plus 1. So number now is 4. And 4 greater than 3 or not?
Yeah.
Yes.
Yes. Exit the loop. So actually the output of this one is a 2, 4, and 6 here. You got it?
Yeah, I got it now.
Yes. So when you compare the first one you only print out 2 and 4 because the condition here, if the number equal to 3, you exit. But this one, you only exit when number greater than 3. That's why you have one more output here. Okay?
Yeah.
Make sense?
Yeah, I got it now.
Okay. Okay, so what about this one? What will be displayed if the code is corresponding to following pseudocode is run? You assume that the user is 17 years old, right? What do you think? What should be the output for this one? You can think about that. Actually, this one you just do it, yeah, by iteration, and you think about that. Okay. So now let me move on to this one. What do you think? Each of the following condition is true or false, right? So how about A? Is true or false?
True.
This one is a logical, right? This one is a logical here. This one is true. How about this one? The second one.
False.
Yes. How about this one?
False.
False.
How about this one?
True.
Yeah, true, right? How about this one?
False.
False.
And how about this one?
True.
True.
Yes. Okay, now you move to the 5.4. If C1 is show and C2 is show here, this one is capital. This one is lowercase. So indicate whether each of the following is true or not. So what do you think? If C greater than or equal to and here or not? Correct or not?
False.
Why false?
Because Joe's value is less than Anne. Wait.
No.
No. Hold on.
No. Remember, if you want to compare string together, right? If you want to compare string together, you always starting from the left to the right, and you compare every single.
Oh, wait. J is greater than A, right?
Yeah, right. J is greater than A because A is a 65 and J is something more than that, right? So this one is true here. Okay. So now what is the second one? You have to remember about the order priority here. So when working with the arithmetic and when working the logical, you remember that you always have to working with the parentheses first, right? You working the parentheses first, and after that you working the ending here, second here. So what happened? You see 1 equal to Joe here, correct or not? This one.
Yes, correct.
True, right? You have true here. So now C here equal to the mole or not?
False.
4. So true and false. What do you have?
False.
Yes, true and false. You have false here, right? Now for this one, C1 equal to 0 here, correct or not?
Correct.
Not correct. You have
Oh,
space
wait.
here. Right?
Oh,
you have
right.
Here,
Yeah.
right? So you have 4
Didn't
here.
pay attention.
Right? Okay, it's okay. Now for this one, correct or not?
Correct.
True, right? And C2 here, Mo, correct or not?
Nope.
4. So we have true or false. What do you have?
False.
True or here.
Oh.
Or.
True.
Right?
So true.
Yes. The output of the or is only 4 when both of them is 4. In any other case, they always true here, right?
Okay.
And or you can think about that. The output of the or is true only when at least one of them is true. So whenever you have at least one is true, it's always true. Okay. And what do you think about the C1 here? Less than or equal to 0?
True.
Correct or not?
No, false.
False.
Why false?
Because
Because there's E. Oh, wait. Actually, true. Because Joe is
Yeah, right.
greater than Joe.
So when compare them together from the left to the right, J here matching, O here matching, and this one is longer. So the longer one is the winner. Right? So
Yes.
C1 is less than is correct. So how about this one? C1 equal to C2, correct or not?
Wait,
false.
not
Oh,
false.
true.
4, right? And not
Yes.
a 4 is true here. Right?
True.
That's the way working. That is the way working with the logical and operator here. Okay, so now we move to the type loops. We move to the type loop here. So basically, the loop can break it down into two fundamental types. The first one is pre-test loop, and the second one is the post-test loop. Pre-test loop, that means you have to check the condition first. After that, if it's correct, keep doing it. But the post-test, it always have at least one iteration. And after that, you just check the condition later. Okay, so and think about this one here. You have the post-test here. The post-test, that means you check it later, whatever it is. You have the enter the number, you have to write the number first. After that, you check the condition here, equal to 0 or not, right? And you have done here. Or so the repeat and until it is a post-test because you check the condition later here. And the do and why here is also, right? You keep doing it, write the number, input the number, write the number here, right? And you check the condition why is the number is not equal to 0, keep doing it, and if it's equal to 0, exit it here. That they are the post-test. The post-test is the one that you only have at least one iteration for the loop. And after that, you check the condition, you exit the loop here. For the pre-test condition here, whatever it is, you check the condition first. After that, if the condition here is correct, if the condition here is correct, exit the loop. If not, keep doing it here. Okay, so for the pre-test here, if the condition is checked at the beginning and it's not correct, you don't have to do anything with iteration. You have no iteration in the pre-test here. But for the post-test here, you remember that whatever it is, it always have at least iteration in the loop here. Okay, so now if you come back to my example here, I don't know why I saw it. Let me, yes, this one. What's this one? I think I have another one. Yeah, this one, right? This one here. You see, if you remember about this one, if I have my one sister here, Julia here, and now I put that here. So even that I have only one sister, but I have two iterations here because the condition is checked later here. Right? You see the condition is checked later, and that's why it always print out so the name and one more with the done here. So what do you think? What I have to change in order to have the only one iteration for this one? What do you think? What I have to change here? Huh? What I have to change in the case that I only have one name here? Print out. Okay, so we see now if I run it again, I have Julia here from my sister. Now if I want to exit, I have to put down here, right? And you see the output here, they have a two iteration instead of one here. So you can think about this one. This one is a post-test condition. You see, whatever it is, I enter the name, and I print out the name, and after that, I just check the condition later. This one is a post-test here, right? So we can check it by change it to the pre-test. So instead of print out the name, I can check it first. After that, I print it later here, right? And for this one, I can, let's see, let me run it for you so you have more understanding about this one. I see I have Julia here. Now I have to put the done. You see, I only have one output here. I only have one output here, but actually for this one, you still have one more asking you and enter the mode. So then when the exit here, so I can change it later, right? I can modify it here. Let me do it for you here. So I think about this one. I can modify here so we have more understanding, but you can understand more here. I put the name. I think when I put it nothing here. So see, now I change this one here, right? So the first one I put the name is equal to nothing here. That is just happening in the name here, so I can run it here. Now I put Julia. So I put the done here. Okay, I exit, and this one again, you have this one here, right? Okay, so now what happened if I change it? What do you think? What I have to change for this one in order to have only one iteration here? Right? You have to put it here. Yes, you have to put it here. Yes, and you have to put it one more time here. Okay, so now see, if I put it here, Julia here. I put it here. Oh, sorry. No, I make mistake here. Sorry. I put name here. What? The thing is, it cannot done this for this one. Right? So it's only one output here. That's the one I can have with the Raptor. The Raptor is a little bit. So you put the Julia here. Now put done. See, I only have one output for this one, right? Oh, what is it? Okay, I can clear it here, so you can see more. Now I put the Julia. I put done. You see, I only have one output here, right? For Julia here, and you see, because you have to check the condition before you print it out. That's why you only have one output here. But again, if you change the condition to the port that here, you have the two condition. You have two output here, right? Julia here. Now put down here. Okay, for this one you have two iteration here. So by working with the loop, you also have to pay attention on the if you want to working with the pre-test or the post-test here. So it depends on the coding. If you want to do with the post-test or if you want to pre-test, you remember that sometimes for the post-test here, you always have at least one more iteration with the program here, right? Whatever it is. So now think about this one. I said enter done here. I enter done here. It print out the done here. Right? So whatever it is, if you're working with the post-test, it always have at least iteration in the loop. But if I want to check the pre-test here, I want to change it. Sorry, I wanted to change it pre-test here. See, I put the done here. I don't have iteration in the loop here, right? You see, I have no output for this one. Okay, it makes sense. Hello?
Yeah.
Okay.
So
Makes sense.
with the post test, we would have no iteration, right?
So for post that you have at least one iteration. For suppose that, right? Because you have to do everything inside the loop first. After that, you check the condition later. That's why you always have at least iteration in the post stat here. But for the pre-test, you can check the condition first. After that, you do something inside the loop. That's why for the post test, sometimes you don't have any iteration here.
Okay.
Okay. Or you can change to this one here. You can change this one here, and you have one more with this one. Okay, so for this one, you can see if I enter down here, user exit program. Okay, user exit program, you have no iteration here, right? Because you have the pre-test check here, the pre-test check here. Okay. So now come back. Hold on. Okay, so if you look on the flow chart, you see you have the pre-test and the post-test loop here. You see for the pre-test, you always have to check condition first, right? So if you work, it's true, keep doing it, keep doing it, keep doing it. If no, it exit program. So we see that's when you enter something is not correct, you just exit the loop immediately. You have no iteration here. But for the post-test here, you see you have to do something with the inside first. After that, you check condition later. If yes, doing it, if not, exit here. So when you compare them together, you always have at least one iteration here in the post-test here. Okay, so sometimes you have to change the loop and you have to walk through it manually. So you can see how it works for this one. And if you look on this coding here, so what do you think? What should be the output for them? Think about it. The first thing, if you look on this one, the first thing, if you look on this one, tell me they are the post-test or pre-test here. Okay. Tell me they are the post-test or the pre-test loop. What do you think?
Post-test?
Now you see, you have the check condition here first, right? You check the condition first. If correct, you do it. If not, you exit here. So actually, this one is pre-test here. And if you look on this one, whenever you have the Y and NY here, they are the pre-test. That means you have to check the condition first. If correct, you do it. If not, you exit here. So you see, if you look on this one, the condition here is to check first. After that, you do something inside the loop, right? So for this one, they are pre-test loop here. Okay, so what do you think? What should be the output for this one? Okay, if you think about if the user enters the number 3, 1, and -1 here, so what should be the output here?
9.
And tell me what are the outputs? It's not only 9.
Oh, 9. 1.
1, 9, 1, and it's minus. Is it also? So is it 9, 1, and 1?
Yeah.
Is it correct?
Yeah.
Yeah, because minus 1 squared is 1.
It's not so that's why you have to change. You have to change the loop here. You have to think how it run. You have to look on the coding here, how it run. So now what happened here? Now tell you, enter the number, right? Enter the number, enter 0. So now enter the number, right? The number 3 here. What happened? Number 3, check the condition here. 3 greater than 0, correct, right? So we write
Yes.
number square here, you have 9 here. All right, so you write out the enter the number 0 to quit, input the number. All right, so next one, you input the number. Now, if you input the number 1 here, if you put the number 1, check the condition here. It's the pre-test, right? You check the condition here. Number here greater than 0 or not? Number
Yeah.
1
Yes.
greater than 0. Yes, right? It's a 1 here, right? Because 1 square is 1. And now enter the number or 0 to quit. So now he enters the number -1 here. You see, if we have to enter the -1, what happened? You check the condition here. The number -1 not greater than, right? So we skip everything here. Skip everything here and exit the loop here. So actually for this one, you only print out 9 and 1 only.
Okay.
You got it?
Yeah, I got it now.
Yeah, that's the way you check when you change the loop here. You have to walk through the loop manually. Sometimes if you want to analyze the coding, if you want to debug the coding, you have to manually walk through the coding and to see what is really happening here. And you see, that is the case, you see. That's the case you can modify from the post loop to the pre loop here. So in this one, you have to check the condition here. If the name is not done, you just print out the name. If equal to done, you just exit the loop here. Okay. Okay, so one time about the counter control loop, that is very, very important here. So think about, you want to write the coding that if you are the teacher and you want to input the grade for a student, right? So you think about if you have the class with the 30 student, so instead of asking enter the grade, it should be better that you tell the teacher that enter grade for the first student, enter the grade for the second student, and the grade for the third student. It makes more sense as it have to avoid from the confusing here, right? So in that case, it should use a counter here. It should use a counter control here. So then normally it can be named as a counter, count, or I, or check, whatever it is. And normally for each iteration here, you enter it's the count and value here, you increase by 1, right? So we think about the first time you enter the grade for the student 1, the next one you enter the group for the student number 2, number 3, number 4, and so on here. Okay, so think about this one. If I can modify it here. I can modify it here. So I can put it a cow here. Right, I put it cow here. At the beginning, I set the cow 1. Right, that's a cow 1 here. So let me modify this one. Okay, so now enter, I don't use enter the number here. Okay, so if you look on this program here, I maintain a count, and at the beginning I set it count number 1. So I can see that how many number I enter, right? So I can enter number 1, number 2, number 3, number 4. It makes more sense, right? So you have ideas that how many number you already enter here, right? So I think it's number here, not name. sorry, I have to change it number. 0 here. Right. And there's a number cow. I can have one more output here to tell that. And the number 0 to exit. Always tell the user how to exit program, right? So I have number here. If number equals 0, exit. Sorry, 0 here. Okay, so now I run it here. So if I see at the beginning, you see the cow here is the 1, right? The cow here is the 1 at the beginning. Where my program? Sorry. I stop it here. Run it. Oh, sorry, I number. I put it here. I have to change this one. Okay, so we see this one is a pretest loop, right? You have to check the number. If the number is equal to 0, you exit the loop. So now I run it here. Cow equal to 1. Number is not. Number at the beginning is 1. I set 1, so it's not correct. Keep doing it here. Right? Keep doing it here. Now enter the number. You see, it makes more sense. I know that now. I enter the number 1 here, so I can put a 65. I print now 65, and you see the cow here, number 2 here, right? The cow now is number 2, and you see, tell me you enter the number 2 here. So it makes more sense for the user. If you think about, if you enter for 100 or 1,000 the time, it makes more sense if you maintain the counter here. You know that you already enter the number 2, number 3, number 4, number 5, number 6 here. So remember, for this one, you always have to maintain it variable. It can be cow, or can be counter, or can be I or J. And one more thing here, when working with the cow here, you always have to initialize the value. That means at the beginning, normally you set it 1. You set it 1 here, right? So for every iteration here, you have to increase this by 1. So the first one is the 1, the second one is 2, the next one is 3, 4, and 5, and go on here. You got it? Make sense?
Yes.
Okay. So normally you see, if you want to counter control loop here, you have the common value name is the counter cow or ij, and normally you have to set the value at the beginning. It can be 0 and 1, right? So for every iteration of the cow, you have to increase by 1 here. Normally it have to increase by 1 here, and it's a counter here. You can use a counter here. So if you look on this one, if you look on this this coding here, what do you think? What should be the output here? If you see the coding, you have a positive integer, you have cow, and you have the input a positive integer. It says cow equal to 1 here. That's the thing you have to initialize for the counter here. And this one is the pretest loop, right? You have to check if cow less than positive integer, you write down here, and you increase the cow and go back to do with loop. I check the condition again and keep doing it here. Okay. So what happened? If you look on the coding here, if the user enters a positive number at number 5 here, so what do you think? What should be the output for program here?
Is it 3?
Think about that. Now you have to manually change it, right? You have to. So think about what happened if we enter the number 5 here. All right, number 5 here. So we have to write down. You need a paper, and you have to write down the program, and you have to change how many iteration and how it work here. So now you see,
20.
if you enter the positive integer number, it's a 5 here, right? 5 here. And at the beginning, you set the count equal to 1 here. And count is now 1 less than positive number, right? 5. That means that the condition is correct. So in the condition is correct, you have to do everything inside the loop here. So you have to write what's the count here? 1. Right? And count square, what is it? 1 here, right? So now what happened? Set the count equal to count plus 1. So now you have the count now is the 2 here. All right. You go back to the loop, yeah, right, and check again. 2 less than 5 here, right? It's correct. Do again. Right. What's the count now? 2 here. Yeah. Right. And the count square 4 now. Right. 4. So we actually print out 2 and 4 here. Count now 3. Move to this one. Count now 3. 3 come back to the condition. 3 less than 5, correct? Right. So again, you print now 3 here and square here have 9. Now count 4 for this one. 4 here, come back to the condition. 4 less than 5, correct? Right. So we have 4 here, and you have 16 here. Now you move to this one. You have to count 5. Count 5, come back. 5 less than or equal to 5, correct? Right. So we have 5 here and 25 here. Now count 6. So count 6, come back. The condition here not correct anymore, so we skip it here. Right? Skip everything and exit program. So actually the output will be 1 1 2 4 3 9 4 16 and 5 25 here. Got it?
Yeah.
Okay.
Well,
so
I am a little bit confused where it says write the count plus, and then I guess the number that would be in there. It seems like you're supposed to add all of them together and then do the exponent. You know, like I was thinking for the first one, 1 plus the in the parentheses, and then 1 to the 1 power. Yeah, I don't know. I was just a little confused there, but I got it now.
Okay, okay. Or you can write the program here. If you want, you can write it in the router. Yeah, you can router and try to see what happened if you enter number 10 here. So what is the output? You can write this in router if you want. And try by yourself to work in the router. If need my help, so let me know.
Oh, yeah, no, I see where I messed up. Where it says write is basically an output, and I was trying to use that as an assignment. That's where I messed up.
Yeah, right. Okay, so now move on. So when working with counter, it can be counter up or down. It's up to you. And the step here is or not always 1. It can be step by, it can be increased by 2, by 4, by 5, whatever it is. Right? So think about if you want to print out every even number from 0 to 100 here. If you want to print out even number from 0 to 100 here. So it's starting by the 0, right? So every time here, instead of increase by 1, now you have the number here. At the beginning, you set the number 0 here, right? So now you check, you have a y number greater than 0. You exit, right? Y number greater than 0, you exit here. Oh, no, it's actually for this one, you have to write y the number less than or equal 0, 100 here. So if the number less than or equal 100, keep doing it, right? So you write number, and for every time you have to increase the number by 2 because you want to print out the even number here, right? So that's why you have number equal number plus 2 here. All right, so that you have ny here. Ny. So we see at the beginning you set the number 0. Check number less than 100, correct, right? Print out 0. Now the number 2, keep doing it. Number 2 less than 100, right? The number 2, keep doing it. 4, 6, 8, 10, and whatever, right? So we see when working this counter here, it's totally flexible with that. It can be step of 2, can be step of 5, or can be step of 10, whatever it is. And you also have to able to print out in the you're working with the count up or count down here. So think about now I want to change it. I want to print out the even number from in the descending order from 100 to 0 here, right? So instead of that, I change it at the beginning here. I change it to 100 here, not 0. So why number now? Why if the number I change it here? If the number greater than 0, right? If the number greater than or equal 0, I keep doing it. I write the number, and now number equal number minus 2 here. So we see at the beginning 100, the next time 98, 96, and keep doing it until the number less than 0. Okay. So by working the counter, you always totally able to flexible with that. It can be you can use a count up or count down. It can be the step of 2, step of 5, step of 10, whatever it be. Okay. So if you look on this one here, it's about count down for blood up here. So we see at the beginning you set the count 100 here. So write down the count down in. So why the count greater than 0? You keep doing it, right? So we have 100 seconds. So every time you decrease by 1, so next time 99 seconds, 98 seconds, and keep going on until it's reaching to 0 here. It makes sense?
Yeah.
Yes.
Yes. What's your question?
Well, I think we'd probably learn it later on, but we could actually put like real time in into the programs, right? So that it would actually use actual seconds.
So if you want, you can do with the Raptor here. So I can wait. Okay, so try to working on this one or with the Raptor. Try to work with this one with Raptor. So if you need my help, let me know. We have a plenty of time. So if you want, you can do it.
Okay.
Okay. So you done?
Yeah, pretty close.
Yeah, I'm done now.
Okay. So if you want, you can share the screen. Mulia, I make it also cohort here. If you want, you can share screen so I can make some.
Right.
If you want, it's
Yeah,
great.
yeah, here. Yeah, this is what I have.
Yeah, that's great. All right. So this one you can you have the option to allow the user enter the time here, right? So if he can enter 100 or 10 or 50 here, right? It's okay. And or if you want, you can at the beginning you can set the time equal to 100 here. You don't have to add the user enter the 100 here. Normally for the countdown time is starting from 100, right? Something like that. So you can set set assignment and set the time here equal to 100, and you don't have to ask user to enter the time here.
Hmm.
Yeah. Oh, but anyway, this one is very good program. Yeah. Very good
Thank you.
program. Okay, so now we move on. If you look on 5.6 here, the following program is supposed to input number from the user and display them as long as 0 is in enter, but statement is missing. What is missing statement? Insert it in proper place. What do you think? If you look on this one, what do you think? What is missing here? And how can you correct it?
Not so sure about this one.
It's a possible infinite loop if the user doesn't enter 0.
What do you think? What's missing here? Now, what happened if the user enter number 10 here, right?
Yeah.
The number 10 here, number 10 is not 10, correct? You write the number, right? So what happened? What happened?
It writes 10.
Yes, so what happened next? What happened next?
Oh, it loops.
Yeah,
It loops.
it's an late loop here. If
Yeah.
you enter the number 10 here, right? So the 10 here is not equal 0, right? 10, come back to check the condition. 10 here not equal 0, right? 10, and keep doing it forever here. It is infinite loop here. So how can you correct it?
And while and while a number is not equal to 0?
No, here's the thing. you have input number, y is the number not equal to 0, y is the number, right? So after that, for every iteration of the loop, you have to ask a username, enter the new number, right? So you have right here, right, enter a new number. You put it after this one, right? You put it after this one. So we see after you enter number 10 here, bring down number 10. Now you enter the new number and enter 0 to exit. Enter 0 to exit. So see, the next time if you enter number 5, you check your condition again. It's still correct. You bring down the number 5. And the next time if you enter the number 0 here, come back, you check here, 0, exit it here. Right? So it's actually the missing here is the problem. You have to tell the user that you have to enter the new number. It makes sense?
Yeah.
All right, got it now.
Okay. Now we move to actually so if you remember that you have two type loop. You have the pre-test loops and you have the post-test loop here. So for the pre-test loop, you have the y, you have y here. You check the condition. You check the condition. You have ny. That is post-test loop, pre-test loop, and you have the post-test loop. You have repeat. You have repeat. Just doing it until you have a condition here, or you can have the do. Just doing it, and you have do y here, right, and y here. So let me come back to see what is the correct structure of that. Yeah. So we have a post stat here. You just do it first and check the condition later. You have repeat until, and you have do and y here. You just do it and check the condition later. For the pre-test, you check the condition first. After that, you do it. That is the y and ny here. Okay. Now we move to the one more pre-test format. It's the for here. The for loop, and most of the language have the shorter method called is for loop here. The first thing you have to initialize the counter, right? And so after that, you can increase or decrease the counter, and so you have the condition also. So when the condition met, you exit the loop here. Think about the first one. You have the for here and have counter. You have initial value, right? So after that, you check the condition here. That's why you have the pre-test loop here. You check the condition, right? And after the condition met, you just increase or decrease the counter. If you have the counter plus here, actually you have counter equal to counter plus 1 here. Or if you want to increase the counter by 5, you can the counter plus 5 here. Right? And it's up to you. It's up to you to you modify this one here. Okay. So for the initial value for the loop, its initial value can be the integer constant here, can be 0, can be 1 or 25 or whatever here. And it can be another numeric variable here. So it can be set to the expression of the another variable. So you set the count equal to lower number plus 3 here. And you have the test condition for the loop. The test condition for the loop. So if the condition is true, keep doing it here. And so we have some of the condition here, some of the test condition. You can set the count is less than 5. So if the count is less than 5, keep doing it here. Or you have a count greater than or equal 6. If count greater than equal 6, keep doing it here. Or you can compare to the another variable, or you can compare to another variable and adding or subtract any number here. It's totally flexible. And for the increment and the decrement here, you can set count equal to count plus 1 or count equal to count plus 1 minus 1, whatever it is. Or you can if you want to change that to 5 or 3, you totally flexible with that. Right? So think about if you want to print out the even number, you set the count equal to count plus 2 here, because every step here 3 here, right? So here's the example here. Here's the example. All right, so you see, you set that one is initial value. So for the count here, you only have the initial value here. All right, so we have the set count equal to the 0, And you always have the condition here to check. This one is condition. This one is condition here. And this one is it's a counter here, right? Counter. Okay. This one isn't necessarily. This one is a step, counter step here. Right? So now, if you look on this one, if you have a cow equal to 0 and the condition here, it keep doing it until if the cow less than or equal to 15. Keep doing it. Right? So when the cow greater than 15, it exits loop. For each of the loop, you increase the cow by 5 here. So if you look on this one here, you can manually change it, or you can walk through it here. At the beginning, you set cow 0, right? Now we check the condition. Cow less than 15, correct? Right? So we write down the cow. So that's why you write down the cow 0 here. So when you finish with this one, you increase the cow by 5. Right? So now the cow is a 5. Check the condition. Cow 5 is less than 15, correct? Print out the cow, the 5 here. So after this one, you increase it by 5. Now the cow 10. 10 less than or equal to 15, correct? Write down. You have 10 here. Right? And after that, come back to this one. Now cow we have 15. 15 less than or equal to 15 is correct, right? That's why you write out 15 here. And the next one, you have cow now 20. Right? So when you have 20, you check the condition here. It's not correct. That's why you exit the loop, you exit the 4 here. Right? So you can do the same. You can chase down the same with this one here at the beginning. That is initial value. Right? This one is condition, and this one is step here. Step now it decreases by 5. So you see at the beginning you have right down here. At the beginning you have the 15, right? 15 greater than or equal to 0, correct? That's why you print out 15 here. Now when we're done, you decrease by 5. Now count 10. Count 10. This one correct? Print out 10 here. And decrease by 5. Now count 5. Count 5 greater than or equal to 0, correct? Print out 5 here. And decrease by 5. Now the count 0. Count 0, this one still correct, right? That's why you print out 0 here. And decrease by 5. So now count in negative 5. Negative 5 is not correct. That's why you exit here. And you can chase it out. You can chase it out the same with the third and fourth here. Any question? Any question for us? Like that? Okay.
No.
Okay. So sometimes you have to pay attention. You have the precision on the loop here. So if the loop increment is positive and the initial value greater than the limiting value, so we think about this one. You have initial value here. It's a 5. And the condition here, if cow less than 4, but every time you increase by 1. That's why you have never able to working with the loop here. This one is never ever able to do with this one. That's why it's the precision for the loop here. Okay, so now working with the application of the repetition structure here. So the loop, you have many purpose. The loop have many purpose. This calculation covers some of you. You're able to use the input data. So think about you want to do is you want to do something a lot of time, right? Think about it asking the teacher and the grading for the 30 students. So keep doing it for 30 times. Enter the first student, the second student grade, the third student grade, and the fourth, so on and so forth. Right? And you can use the data validation here. Data validation, that means you keep asking the user enter the data until it's the correct format here. So think about if you want enter asking the user enter the number, right? Enter number here. And you make sure you have to validate that the number here is in the number format. So you create the condition here, the loop, right? You have to check is number here. Is number, if is number correct, exit it. If not, asking him, do it again, do it again, do it again until the number until his input the correct number format here. And in the case of the data validation here, you can use the int function, you can use the floating, and you can the ceiling function here. And I'm talking later what is the int, what is the floor, and what's ceiling. And the most common application for the repetition is computing the sum and average here. So think about if you asking for enter grade for the 30 student, right? 30 student here, and after that you're able to sum them up together, and you're able to figure out what's the average of the class here. And we also have the sentinel control loop. So normally the loop often use to input a large amount of data here. Right? So data here. For each pass through the loop, one item of the data can be entered. The test condition must cause the loop to exit after all the data has input here. That's why for everything you all have the test condition here to exit the loop. So often one way to force the loop to end is to use the sentinel value here. Sentinel value. The sentinel value is someone is cannot possible be submitted from the input data here. So think about if you asking the user enter the positive number, right? Everything from 0 to whatever it is, to the positive negative here, and you can use the condition to exit the loop is that whenever he enters the negative number here. So whenever number less than 0, that you exit the program, because you expect to enter all of the positive number. So whenever you enter any number less than 0, you exit the program here. Okay, so here's example of the sentinel control loop example here. You see that this one it keep asking the user enter the hour, enter the rate and salary, and after that you figure out what is salary here, and you see that the hour here normally you say as a positive number, right? It cannot be the negative here, so that's why you set the sentinel control here. So whenever the hour equal to -1, you exit the program. Right? Because in the real life, you have never ever have the hour working hour is -1. That's why you see why the hour here is not equal to -1. Keep doing it here, keep doing it, and you tell him, you have to tell him that enter the -1, you are done here. Okay. Any question for this one?
No.
Okay, so remember the sentinel control is something that it cannot be happen on the real line, and you have no way to mistake with the real data here. Okay, so data validation is a loop often used to validate the data entered by user here. So here's an example, right? So to ensure that the user enters a positive number, you have the widget order, right? So widget order here, how many widget order, and the input is here, and whenever you enter it less than 0, right? So we exit the loop here. So you have to write that you can order the negative number and please enter the positive number of 0 here. So whenever he whenever he enters something less than 0, you have to remind him again that you cannot order the negative number. Please enter the positive number again and keep doing it again and again here. Okay, so you can do this one with the router. Let me show you how it works here. Okay, so for this one, you see, this one is used for data validation. You make sure that the user enters the widget order is the thing that greater than or equal to 0 here, right? So you can do the same. You have how many widgets you have order. This one is input, right? And you store it in the variable name. What's the variable name? Why should order here? Okay, so now you see, you check the condition here. This one is a pre-test loop, right? You check the condition first. So if y is less than 0, I will show you something when working the router. It's a little bit different here. Okay, so here, what do you think? If you look on the router, you see this one condition, this one condition here, and whenever it is. So if the condition is yes, you exit the loop from the router here. Right? So when remember that when working with the router, sometimes you have to modify the condition here. So in that case, you want that if the YZ order greater than 0, you exit the loop. Right? If not, see if the YZ order here greater than 0, you exit the loop because this is the validated data. And if not, you have to force them to enter again. So we have to force them to enter again here. That we cannot order negative or number YZ here. Okay, so we see what happened here if I enter the number 10. It's okay, right? Number 10 is that because after that you check the condition here, correct? Exit it and do it later. So you can do the other calculation here, right? Exit it here. Now what happened here if I enter the negative 10 here, right? It's a negative 10, you check the condition not correct, do something here, right? And tell you that you cannot order the negative number, you enter a positive number. Now, if I make another mistake, I enter the number negative 5 here, again, you check the condition, it's not correct, it forces you, keep doing it until you have the positive number here, right? So we have a 20 here, for this time I exit the program here. Why I put 20 here? What? Oh, my is not correct. Sorry.
Oh,
So
yeah. Your variable is inconsistent.
Yeah, right. That's good. So I have to change it here. Yeah, that's very good observation.
That's
Now-
still wrong.
Really? Oh, yeah. Yeah.
You tapped in widget W's and widgets.
Anyway, you know how to do it, right? Sorry for that. Okay. So that's the way you're working with the validation data here. So in the case that you have to force them, you are able to force the user keep doing it until he enters the correct data here. So you always have to flexible with the condition here. And remember that in the router, whatever it is, whenever the condition is true, you exit the loop here. That's why sometimes you have to modify, modify condition here. Okay, so now we move to the int function here. So sometimes you want the and sometimes you want the user enter the integer number. So you want to you asking him to enter the number 1, number 5, number 10 or 20 instead of 5.7 or 5.3 or something like that. Right? So in that case, you are able to use the int function here to verify that he already entered the integer number. So by doing that, you can work in the router. Let me show you how to work in the router for this one. Yeah, enter the number here, right? And you can check it here. So remember what with working the inter number. So if you enter the 7.5, it return you the integer part here. So think about this one here. Okay, so if you have the integer number, it's a take any number and turn it into integer. So we think about if you have numbers 15.25 here, it turn you the integer part here, right? And skip everything about that one. And if you have about the negative 473 here, it skip everything about the this part and only keep the integer part here. Right? So when you're working with the Raptor, you're able to verify. You're able to verify and to make sure that end user here enters the integer number here. Right? So think about this one here. You're asking him enter integer number here. Right. So now you have to check. You have to check if its number here is an integer number or not. So you're able to check it here. Number to in number here. Oh, I think in the Raptor here, they're not allow you to do that. So you have to use a floor here, floor function. In the Raptor, they don't have the in function. So we have to use the floor function. If not, you have to tell him that you have to enter. Okay, so now come back to this one. I tell you what is a floor and what is the sharing function here. Okay, so that basically for the in function, normally for most of the programming language, they support the int function here, and it return you to the integer part of the number. And so if you want to make sure that the user enters the integer number, you can check it here, right? So integer number my square equal to my square here. So make sure he enters the correct integer number here, right? So in the Raptor here, you can use the floor and ceiling. The floor is that you return you round out the number here. So think about if you have 15.72, it you round it down to 15 here. Round it to 15 here, or you have the 7.27, it round down to the 7 here. And if you have the negative 4.95 here, what do you think? If you have negative 4.95, so what is the output of the floor function? Any answer?
Not so sure about this one.
Remember, for the floor, it's round it down to the integer number. So if you have negative 4.95, so what is the integer number for this one? What is the output of the floor function? You remember that you have a round it down here. What do you think?
Would it be -4?
No,
Yeah.
negative 4 is the greater than. Right? You see, if you look on this one, you have negative 4 here and negative 4.95 here, and you have negative 5 here. So when in the case of the floor, you have to round it down. So we have to round it down to negative 5 here. So the output of floor function for this one actually is a negative 5, not negative 4. You got it?
Yeah.
Okay, that's the case you have to remember. And the ceiling function is everything you round it up. You round it up here. So for this one, 15.72 here, you round it up, you have a 16 here. And this one, you round it up, you have 8 here. And this one, you round it up, you have negative 4 here. That's all. That's the only difference between the floor and function. Both of the function will round it to the integer number, but the floor, it round it down, and the ceiling, it round it up here. It makes sense?
Yes.
Okay. So in the case here, if you can use the floor or ceiling function to make sure that the user here he enters the integer number here. Now I run it here. So if I enter the number, I can print out the number if you want. Let me do it. No. Okay, so I output here. Not this one. I can see this one. Okay, so now if I run this one, I have, if I enter the integer number 15 here, it's correct, right? That exit program. Now if I enter the 15.75 here, it's not the number, right? So you see, it's asking you have to enter the integer number here, right? So now I put the 15 here to exit it. What is it? Again, I make mistake here. Okay, no. So I think I had to do a little bit modified here. I put it outside this one. Okay. So I put the integer number 15. You exit the loop, is correct. Now if I put the integer number 15.76 here, okay, force you to enter. Now I put the 20 here to exit. Okay, so we see the floor of this one here is a 15 because it round down here, right? So now if I enter the negative number here, negative 4.97 here, 98 here, 20 here. Okay, so we see the floor of the negative 4.98 is a negative 5 here because it's round down, right? It's round down here. So it makes sense.
Yes.
Makes sense. So we see you can use it here. You can use it condition here to make sure that if the enters the integer number, you can change it to the floor. It's the same. Sorry, to the ceiling is the same. You make sure that he enters the correct integer number here. I can change it here and the ceiling. Now I can do it again. So if I enter the number 20, it's correct. Exit. Run it again. I enter the negative 4.94, 86, and something like that. Now 15 to correct. Okay, so we see the floor of the negative 4.567 is a negative 4 here because it rounded up here. Okay. Any question for this one? Any question?
No.
Okay, so we see you have the sum of application already, right? So the first one is that you have sum of application here. Yeah, you have able to use to input data. You have able to use the data validation here. So we can use the integer, floor, or ceiling function, or you can use the sum of the function, each string, each character, or each number to make sure that he and the user enter the input in the string format, in the character format, or in the number format here, right? So if you're working with the router, you have a sum of the function you are able to use. You're able to use to verify here. So what happened here? If look on this one, what happened if I run this one and I enter the wrong one by the character here? I enter the character here. You see,
Program will crash.
it's a crash here because you cannot compare the number. You cannot compare the string with the number here, right? So in that case, you can make sure that he enter the number format by using the function here is number here. You see, you have the is number here, is number, and have number here. Okay. What am I missing? I think I have to change. The value, the variable name here. Oh, maybe, sorry, is here. Right. Okay, let me check it again. I guess. Yes. Why? Is number one. I don't know what happened here.
Maybe you have to change the.
Sorry, number one. Please.
Variable.
Okay. No. Why? Let's see. I don't know what happened. Let me do it again. Sorry. Yeah, okay. I think I made a mistake here. Oh, what happened? Oh, sorry. My mistake here. I make a really mistake here. This one only. This one actually is only. So this one is giving out the true or false only. It's not the compared to this one. So this one is that if it's a number here, it's a format number correct or not. Yes, my stupid mistake. Okay. So it's number here. You know that this is a number format, right? And if not, you have asking him. You're asking him to enter. You have to enter the number here. You have to enter a number format. Because this one is logical. So if you enter is number, it's correct. It's true. It exits here. It's not. It keep doing it here, right? So now if I enter it again, okay, it tells you that you have to enter a number here. I put the 50 here, correct? Right. So we have this one. It makes sense. So now sometimes if you want to make sure that you want to make sure that the user have to enter the number, and it is integer number, you can use a combination here, right? You can use a combination here and here, and number equal to floor here, number here. Okay. So in that case, you are able to make sure that he enters the correct number, and he enters the integer format here. I shall see for this one, if I enter the correct number here, 57, but it is not the integer number here. Right? So asking it again, what? Why number not found? What's the number not found? Okay, again, I make mistake here. Oh. Yes, so now you see if I enter the correct format, it's number here, but it's not integer. See, it keep asking me again, right? So now I put the correct format here. That's exit here. Okay, it makes sense to you. Okay, so you're totally flexible with the data validation here. You can check if the if sometimes you can, if you want to enter the username, you have to make sure it is a string here, or if you make sure that he enters the character. You can use the is a character here, right? That is totally you able to totally flexible with the data validation here. Okay, so now that is a very common application of the loop. It computes the sum and average here, the sum and average here. So this one you see, you keep enter the positive number, right? Keep enter the positive number, and remember that the condition is that if you enter the greater than 0, keep doing it and sum them together, sum them up together. If not less than 0, you exit the loop here. So this program here is asking user to enter a lot of the positive number. A lot of positive number, and when he enters the number 0, exit program. And after that, you have to tell what is the sum of all the number you enter here. Okay, so try to work in this one with try to work this one with Raptor. Try to work this one with Raptor here. Do it, and if you need my help, let me know, because this one is the most common application in the loop here. Have we done that? Finish? So one thing about the sum, when working the sum here, you always have to initialize the sum. That is the accumulator here, right? So you see, at the beginning, you have to set it to 0. So whenever you enter the new number, you just add it up to the sum here, right? So we think about at the beginning, you have 0. If you enter the number 5, now sum is 5. 5, right? If you enter the number 10, now 5 plus 10, you have 15. If you enter the number 20, now we just sum it up together. It is an accumulator here, right? So remember, when working the sum, the first thing you always have to initialize the sum. And after that, whenever you enter the new number, just add them up together. That adds up together, right? So we see you have the sum equal to sum plus number here. So we see at the beginning 0 here. Now sum is if you enter the number 5, so sum is 0 plus 5, you have 5 here. So next time you enter the number 10, so sum is equal to the sum, the 5 plus the 10, you have 15 here. That is accumulator here. So if you work on this one in the adapter, you can see you can work it by work it here. Okay, so the first thing you have, let me open this one so we can see what is going on here. Okay, so we see you have at the beginning you have set the sum equal to 0 here, right? That is the accumulator here. Put 0 at the beginning. Now asking him and the okay, so now have the loop. The first thing you have to check to make sure that that is a positive number, right? So why is the number greater than 0? Keep doing it. Right. But you see in working the graph here, you have to change the condition. Right? If the number greater than 0, you see if your number greater than 0, exit the loop here. Right? So in the router, you have to change the condition here. If the number less than 0 or equal to 0 here, right? Equal to 0, you exit the loop, right? If the number equal to 0, it's exit the loop. If not, keep doing it. Enter a number. I think it's enter the number here, not positive. Here. So now what happened? If the number not equal to 0, you just sum it up together, right? So we have assignment here. You have the sum, the new sum equal to the old sum plus the number you just enter here. Okay, that's all. And after that, you just ask him to enter the new number, and after that, you just print now here. Yes, that's all, right? So see if you run here, you enter the number 5. See the sum now 5, right? So if I enter number 10, now it is sum it up, you have a 15 here. Okay, so you see 15 here. Now I have 20. Sum it up, you have 35 here. You see, you have 35. Now I want to enter exit, you enter 0. Exit it. The sum is the 35 here, right? So that is the way working with the sum. Remember that when we want to do with the sum, you always have to initialize here. The sum is 0. And every time you enter the number, you have the sum equal to the old sum. Sorry, the new sum equal to the old sum plus the new number here. That's all. That to accumulate it here. Got it?
Yes.
Okay, so what happened here? What happened if I want to figure out what is the average of the number I enter here? So what do you think? In order to figure out what is average, what I have to do now? What is missing on this one? What I have to do?
Do you need to add one more assignment, right?
So you need to figure out how many number you really enter, right? So for this one, if I enter 3 number, I have to take the sum divided by 3. If I enter the 4 number, I have to take the sum divided by 4. So in order to do that, I have to maintain the counter here. I have to maintain the counter to know that how many number I already entered here. Okay, so for this one, I need one more counter. I see the counter here. I set this counter. So the counter at the beginning, I set the 0 here. So every time if I enter the number, the counter increased by 1, right? So it's a counter increased by 1 here. So that's why I have a counter. Sorry, why I make the comment here? Counter equal to counter plus 1. Okay, so the sum is okay. Now what is the average here? Average is take the sum divided by counter here, right? The average is sum divided by counter. I don't know. So now see how it works here. Let me clear this one. Now I see how it works. I enter the number 5 for the first one. You see the sum now 5 and the counter now 1. If I enter the number 10 for the second one, now the counter is 2 and the sum is 15. Now I enter the 15 for the third one. The counter now is 3 and the sum is 30. Now I exit program. Okay, so see the sum is 30 and the average is 10 here. Make sense? Okay, so here's the two things you have to remember. So in the case of working with the sum, you have to maintain the accumulator and you have to initialize the accumulator is 0 at the beginning here. And after that, you just add them up together. And in the case of working with average, you have to maintain the sum and you also have to maintain the counter here. The counter tell you how many number or how many items you already enter, right? So remember, every time you have a new number, you just increase by 1 here. And after that, you take the sum and divide by the how many number you have. Okay, that's all. That's the way working the sum and average here. Okay, so we have the sum of the length of function. You have index, ASCII to the character. I will talk it later. So I think that's all for today. If you have any question, let me know. Any question?
Not
I'm
at this
good.
time.
Okay, so if you don't have any question, I see you guys on Thursday. Okay, on Thursday I'm working with a review and working with the homework assignment. And this week we have the project report also.
Okay.
Okay, so see you guys on Thursday. Bye bye.
Too.
Bye.